This is part 3 of the fuel injection controller. This part is going to deal with a quirk in which Andy has discovered that the IDM will not drive the injectors, even though it's commanded to do so. We're going to start with an RPM that works first of all. 3900, 3.05. Okay, obviously that sounded like it was working. We see a valid signal. We'll comment on this signal. Ejection event starts. Magnetic field begins to build. At some point, magnetic field approaches saturation, probably pretty high on the knee of the magnetic curve. At this point, the current limiting turns on. This phase is a 20 kilohertz closed loop cycle. Now at some arbitrary value, it shuts off. Now that we already have the injector saturated, we have roughly the equivalent of the saturation time to shut off before we have to give it any power to maintain the electromagnetic field. Which if you look, you see that the on pulse and the off are roughly equal. At this point, we enter a 50 kilohertz closed loop current limit in order to maintain the magnetic field and keep the injector energized. At which we de-energize the injector, the magnetic field collapses. It has a peak inverse voltage as the magnetic field collapses, which is ultimately absorbed by the flyback diode in the IDM, logarithmic function, which eventually works out to 0. The event starts all over again. Now, we're going to exploit this. We're going to use the same divide time, 500 microseconds. All we're going to change is 1/100th of a millisecond of fuel, and it's going to affect this pulse adversely. (3900 RPM), 3.06 milliseconds of fuel. Obviously, that is not running properly. We hear it missing, cutting out injectors. Now when we look at the pulse, we see a very different picture. Remember, this is 500 microsecond divide. If you can see one square there, we're roughly half of one square, so that's 250 microseconds of pulse. The injector never reaches saturation, which suggests that it probably never opens entirely. It is cut off. We see standard flyback, standard logarithmic function for the diode absorbing the signal, and it flatlines. This is obviously not ideal operation, and this may be the cause of the hiccups and coughs and the pulling trucks at higher RPMs. Further research is needed here to verify this, and this is the end of this section.